This video is over identifying functions test review problems. For problem number 1, we have the point 46, we have the point 64, 82, and 28. When we're looking at points, we look at the x value, which is the first number, 4, 6, 8, and 2. Those are all different numbers. They're only used once, and so number 1 is a function. For number 2, we have the points -1, 10, 5, 10, 8, 10, and 0, 10. Again, to decide if it's a function or not, we look at the first value. So the -1, the 5, the 8, and the 0. All of those numbers are different. None of them are used more than once, and so number 2 is a function. For number 3, we have the points 3, -5, we have 8, 6, we have 9, -10, and we have 3, 5. Again, for points, you're looking at the first value, 3, 8, 9, and 3. The number 3 is used twice, and so that means that this is not a function. For number 4, we have the equation 4x squared plus 5y squared equals 16. This is a function because both x has an exponent and the y has an exponent. If both values have an exponent, it is a function. For number 5, we have the equation 6y squared minus x equals 12. This one is not a function. It is not a function because the y value has an exponent, but the x value does not. Both of them have to have an exponent for it to be a function. For number 6, we have the equation 1/2 x minus y equals 4. This one is a function. It is a function because there are no exponents with our values. If there are no exponents, it is a function. For number 7, we're given a table, and it looks like x, y, and then we have 0 is paired with 2, 5 is paired with 7, -5 is paired with -7, and 0 is paired with -2. We are looking at only the input values, only the x values, so we're looking at 0, 5, -5, and 0. This table is not a function because the 0 is used twice. The x values can only be used once. For number 8, we have another table. Our table is set up as 3 is paired with 4, 3 is paired with 6, 3 is paired with 8, and 3 is paired with 10. This table is not a function because we are looking at only the x values, and the input values can only be used once. The number 3 is used 4 times, so it is not a function. For number 9, the last table, we can set it up as 4 is paired with 6, 2 is paired with 8, -2 is paired with 10, and -4 is paired with 12. This one is representative of a function because when we're looking at the x values, the input values 4, 2, -2, and -4 are all different. Even though the numbers are the same, 4 and -4, one is positive, one is negative, they are different. 2 and -2 are different. So none of the values are used more than once, so it is a function. For number 10, we have a graph, and on the graph we have a picture like this. So when you have a graph, we want to do what's called the vertical line test. So we can draw a straight line anywhere on the picture, doesn't matter, and we put a point at where it touches it. So my vertical line touches the graph one time. One time is a function. The x values can only be used once. For number 11, we have another graph. This graph looks like a backwards C. Again, we can draw a vertical line anywhere on the picture. It touches the graph up at the top as well as down at the bottom. Because it touches the graph two times, it is not a function. The x values can only be used once. The line can only touch the graph one time. For number 12, for our graph, it's a vertical line going straight up and down. So when we draw our line, it's going to touch the line at the top and at the bottom. It touches it the entire time. So this means that it is not a function. Our line completely covers the entire graph. And so that means it is not a function. It touches it multiple times. The x value can only be used once, and the graph can only touch the line one time. For number 13, we have the input values for our map, which are 6, 4, and 3. We have our output values, which are 2 and 1. We can see that 6 is paired with 2, 4 is paired with 1, and 3 is also paired with 1. This is a function because each of the input values has only one answer. For number 14, for our input values on our map, we have the number 2. And for our output values, we have the numbers 4, 6, and 8. We can see that 2 and 4 are paired together. We can see that 2 and 6 are paired together. And we can see that 2 and 8 are paired together. This is representative of not a function because the number 2 has multiple answers. The number 2 is paired with 4, 6, and 8. The input values, the x values, can only be used once. For number 15, our input values are going to be -6, -2, and 3. And our output values are going to be 5, 10, and 15. We can see that -6 is paired with 15, -2 is paired with 5, and 3 is paired with 10. This is representative of a function because each of the input values is only paired up with one output value. The input value, the x values, are only used once. For number 16, we have the problem f of 4 if f of x is equal to x plus 3. We're going to take our x value 4 and we're going to plug it into the x in the equation. So instead of x plus 3, we're going to do 4 plus 3, and 4 plus 3 is 7. For number 17, we have the equation f of 8 if f of x is equal to 3x minus 11. Again, we're going to take our number 8 and we're going to plug it in for the x value. Now, the 3 and the x side by side means multiply. So we're going to multiply the 3 and the 8 and then subtract the 11. 3 times 8 is 24. 24 minus 11 is going to give us 13. For number 18, we have the problem f of -5 if f of x is equal to 4x minus 7. We're going to take our number -5, we're going to plug it into the x value in the equation. The 4 and the x side by side means multiply. So we're going to multiply the 4 and the -5 and then subtract the 7. Now 4 times 5 is 20, so 4 times -5 is going to give us a -20. -20 minus 7 is going to give us a -27. For number 19, we have the problem f of -3 if f of x is equal to -2x plus 9. We're going to take our number -3, we're going to plug it into the x value position in the problem. The -2 and the x side by side means multiply, so we're going to multiply the -2 and the -3, and then we're going to add the 9. Now, -2 times -3. 2 times 3 is 6. 2 negatives make a positive, so 6 plus 9 is going to give us an answer of 15. For our last problem, number 20, we have f of 7 if f of x is equal to 13 minus 3x. We're going to take our number 7, we're going to plug it into the x value spot. Now the 13 has to stay in the front because it stays in the front in the problem. The 3 and the x side by side means multiply, so we're going to multiply the 3 and the 7. 3 times 7 is going to give us 21. 13 minus 21 is going to give us a -8 for our answer.